Hello, calculus fans. Let's find a parameterization of the top half of the cone, z squared equals 4x squared plus 4y squared. Now let's solve for z, and if we do so, we get z equals plus or minus square root of 4x squared plus 4y squared. And if you like, you can pull the 2 out, so we get plus or minus 2 times the square root of x squared plus y squared. Now the top half of the cone is z equals plus 2 square root of x squared plus y squared. Now one way to parameterize this is to use x and y as the parameters, and that gives us these parametric equations. So x is just x, y is just y, because those are the parameters, and then z equals 2 times the square root of x squared plus y squared. Or you could have this as its vector equation. R of xy equals x, y, 2 times the square root of x squared plus y squared. Now there's an alternative representation. What we can do is use r and theta from polar coordinates as our parameters. So what we can do now is to say that a point x, y, z on the cone satisfies x equals r cosine theta, y equals r sine theta, and then when we plug all those into z, we'll get z equals 2r. So we can now write down a vector equation of the cone. Looks like this. Now we want to keep straight our r as the vector function, but we also have an r for the polar coordinate. R cosine theta I, r sine theta j, 2rk. R can be anything that's bigger than 0, and theta, as usual, just goes from 0 to 2 pi. And in a lot of ways, this is a better representation. One reason is that there are no square roots involved. Maybe that's the main reason. Okay, that's all for now.